perimeter. Okay, so this is almost the same as our warm-up. So this says trapezoid A to B. Do I have a volunteer for what that scale factor would be? What do you say?
2 to 1.
Yeah, so 2 to 1. So I'm going to start with A. A is the larger one, so 2 to 1. And I found that by doing, like, matching up just side to side. So 10 to 5.
B is 1 to 2. Yes.
And then B to A is 1 to 2.
Yes.
All right, so area. Do you guys remember finding area of trapezoids some other year in math?
No.
So our formula is just base 1 plus base 2 divided by 2, and then times the height. So we're just finding the average base. So like this one, we would do 10 plus 9 divided by 2 times the height, which is, what is our height, 8 or 6?
8.
8. So height's always our the perpendicular line, straight up and down. Okay, can someone type that in your calculator? Tell me what you got. So 9.5 times 8. 76. Mm-hmm. Okay, and then perimeter is, what do we do to find perimeter?
Add everything on.
All right, so what are my sides? I have 10, what else?
10, 9, 8, 6.
10, 9, 8, and 6. How do I know that this side is 8?
33. It's 8 because 33.
Because that's 8, right?
Wait, what'd you say? It's 33. I didn't know which one's 8.
So this side is 8 because I need the 4 outside ones. And so it's 8 because the height is 8. All right, 33. Can we use the pattern we found on the last page and figure these out without doing the math for that?
Multiply. Yeah, that's what I did.
So 33 divided by 2 is? 16.5. And what do we divide area by?
4.
Yeah, divide by 4 because it has to be divided by 2 squared. What's that come out to? 19. Okay, and we used the patterns we already found. So how does perimeter change?
It decreases.
Yeah, it was just half, right? And then the area changed by? Yeah, 1/4. Or we could say, yeah, we could say the half squared, so it's like 1/2 squared. Okay, and then this one, if we have this, if triangle RST is dilated by a scale factor of 3 to form our new RST, the area of RST is 1 square inch. What is the area of our new one?
Prime.
Yeah, of R prime, S prime, T prime. Well, if the first one's 1, our scale factor is 3. What's our new one?
Dilated. So that means that's 3.
But the area.
The area.
So area squared, right? 1 inch is squared. It goes 1 to 3.
Is it 1, 1, 1? What are you talking about?
So when we're talking area, so here we just divided by 2, right? What did we do when it was area, when it was squared?
About 4.
Yeah, so it has to be times our 3 squared. So when we're talking area, we always do, it's inches squared, so we do the scale factor squared. So it's equal to 9 inches squared.
Oh, yeah.
Okay, that's your shortcut. That's the pattern that everything in this unit will be easier if you know that. There's always like a small part of proofs, but not like the big 2-column proofs that we did last semester. Okay, so these are just some of our formulas and stuff. And so it's saying if 2 polygons are similar, the ratio of the perimeters is equal to the ratio of their corresponding sides. That's what we just found. It matches their scale factor. If we have areas, it's just going to be that ratio squared. And then, do you guys remember in the fall when we did congruent triangles, like side angle side, 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 all of that?
hypotenuse line.
Hypotenuse leg.
Line where it was like.
Okay, so we have now similar triangles which follow all those same ones, except if they're similar, then the ratio of the corresponding side lengths are equal. Okay, and we'll have some example problems, but there's one new really easy one. If you have two angles the same on a triangle, the triangles are similar. Okay, so that was one we didn't use in congruent because triangles can have the same angles but be different sizes. But similar just means they have the same angles even if they're different sizes. Did I just say that in English?
No.
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 Oh, it's Chinese. Okay, so angle-angle similarity theorem. If we have two angles that are congruent, then the two triangles are similar. Is that English? Okay, that's just the rule. So if we have two angles the same, we know for a fact that they're similar. And that would be the proof that we use. If two angles are the same, I can prove they're similar.
So then when we go to do the like two angles,
you just write angle, you just write AA. Alright, flip over to the next page. So our last page of notes for today. Yeah, it's short notes. Today.
Thank you.
Alright, here we go. So, here I just have to match up and find side to side. When I'm doing these, I just set up my ratios because by definition they're the same. So 2 matches up with which side on the second triangle?
3.
Okay, so that would be our scale factor of 2 to 3. And when I set up the problem, the easiest way is just set up my ratios to equal each other. And so x and 7, what should go on top to match the 2? X. Why does x go on top? Yeah, I need x and 2 to line up horizontally, and then the 2 and 3 to line up vertically. And then what do I do when I have this type of problem?
Cross multiply.
Yeah. So 14 equals 3x. And last step? Divide. By 3. What's 14 divided by 3?
No clue.
So 4.6667, and does not tell us what to round it to, but I'm going to round that to 4.7. Does it give us a unit? Are we dealing in inches, meters, or anything? So I'm going to leave it like this. I could write units, but I'm just going to leave it. All right. We're going to take a minute in your group, see if you can do problem 2. Just all we're doing is finding x right here. Figure out how to set that up and solve it. Okay, so those of you who told me that you got x equals 10, how did you set it up? All right. Okay. All right, so we got x over 25. Claire, what did you get other than x over 25?
Yeah, I didn't do it like you did.
Okay, there's several ways to do this, so how did you do it?
I did 25 over 20 and it equals x over 8. Ooh. And then 20 divided by 2.58, so I did 25 divided by 2.5.
Okay, so that's one way to do it. How do you do it, Enrique?
So then it was, I did that equals 12 over 30 and cross multiply it.
And then you cross multiply it. Okay. So you said that's way more work. What did you do, Jacob? 8 over 20 equals x over 25.
No, you're multiplying two base numbers there. It's
not hard.
But you guys have calculators. Okay. Do these all give you the same answer?
Yeah.
Yeah, so see how all these different ways that you set it up, they give you the same answer. What's a way to set it up that wouldn't give us the same answer? Are there incorrect ways? Okay, all 3 at once would probably get confusing. What if I did
2 different sizes?
What if I did like 25 over 20 equals 8 over x? Would that work?
Because the sides are matched up.
Yeah. So these are the rules when we're dealing with these. One rule, I'm going to say it out loud. Can you hear it? Okay. Is we always have to make sure both like side to side and triangle to triangle is matched up. So whether we choose to do this side to this side on this triangle, and then this side to this side on this triangle, or if we choose to do it this way where we match up side to side and side to side, you have to just make sure that you're lined up horizontally and vertically with the same side and the same triangle. Was that English?
Yes.
Kind of? Okay. All right. So let's make sure we're following our one talker. Move on to the next one. These are some kind of interesting numbers here. Because we have some like 3 root 2 different interesting numbers here. What's our scale factor of A, B, C, D, E to K, L, M, and P?
Wait, what?
2 to 3. Okay, so when I'm looking for scale factor, I come and find which 2 sides do I have that both have numbers, and this is the one that has the numbers. So 2 to 3, and then if we start with K, L, M, and P, it would be 3 to 2. So it's just which direction are we going? Okay, so that yeah, so you always put the one they list first. You put that number first.
Are they ever not going to be like that?
They'll always be like this, where you match up in the order this way. BJ. Okay, so we're going to use that 2 to 3 is going to be our basic one for every single thing we find. So X goes along with which number? So it goes along with 3 on the same triangle, and then it goes along with which side here? 1, right? So I just match up side to side and shape to shape. And so then that comes out to what? And if we go ahead and divide that out, it's going to become 1.5. So X equals 1.5 or 3 over 2, depending on format. Sometimes we want one or the other.
Why do you do such easy problems?
Why do you have such easy problems?
Yeah, so practice.
To make sure you have like the basics down before you get to the more challenging ones.
Like, what is this?
What's your question?
How do you do the scale factor with the
Okay, so we square root next. So scale factor is square root. Okay, so we start up, if we're finding y now, we do the same 2 to 3. Equals, where does y go? Mm-hmm. And is y go with the 3 or with the 2? Yeah. So y matches up with 3 root 2. Do you guys remember how to multiply square roots?
No.
Okay, so some people don't. Does anyone remember? Do I multiply 3 times 3 or 3 times 2 or both? 3 times 3. I do like terms, the whole number. So that becomes 2y equals 9 root 2. Okay, so when there's a square root there, we just leave the square root and multiply the whole numbers. And when I divide by 2, so I could do it I could leave it in this format. I could do 4.5 root 2. I could then type in my calculator, find the decimal answer for square root of 2. Generally, like when we get to special rights later on, you're going to just leave it in this format, would be the most common. Alright, what is the last thing we have to find? So we found X, we found Y. So any ideas how we find Z? So do angles follow scale factor or are angles just the same? Angles are the same, so Z equals 45. Okay, so angles are really easy and similar polygons because you don't have to do any math, they just match. I would put 45 degrees, yes, thank you. Alright, 6, 7, and 8 we're skipping because they're just like kind of double examples and a lot of you have to get to your test.
So we have to do our test right now?
So we're doing 1 and 2 on the bottom, last ones. Okay, So what does it ask us to do in these two?
Are they similar?
Okay, so are they similar? Step one.
Two sides.
If they're similar, what do we have to do? If the, write a similarity statement, explain your reasoning. Okay, so explain reasoning is going to be in the format of the angle, angle, side, angle, side, 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 side. We're just saying, hey, how do I know these are similar?
So like AA.
All right, so Jacob figure that one out. What do we do for this one? Someone besides Jacob?
That's 90. That angle.
Yeah, we just do the math. So we do the 180 minus 90 minus 39 to find that this is 51. And so yes, they're similar by angle, angle.
39.
And so same thing, this would have to be 39. And then what is that similarity statement? Do you guys remember that?
It is similar because
So similarity statement is just matching up the corresponding angles and sides. So if I said triangle ABC, this is our similar symbol. MLN. And so I'm just matching up the 90-degree angles, 51-degree angles, and the 39-degree angles. So this is my full answer. See how easy that is?
really easy.
Okay, so those of you that said no, stop and think which part of it's confusing. So matching up the letters is confusing?
No, I was second.
Sometimes it is. If they don't give you angles especially, sometimes it's a little confusing. All right, how about the second one?
Yes.
No.
Yes.
No.
Okay, so I heard yes and no. So when we do 180 minus 21 minus 93, what's that become? 66. So are they similar?
No.
No. Okay, so we have not similar.
The one is not similar. I can't pronounce it. You don't have to put an explanation.
Yeah, we don't have to do anything else. It's just not similar. Okay, I do need to show you one other thing, because I just realized we don't have that example included here. So draw out these two triangles. Okay, so first, what could these be similar by? What have I labeled for you? So the angles match. Do I have a second angle?
No.
No. Do I have any sides?
Yeah.
So which of these three could it be?
Side.
Okay, so it could be side angle side, or it could be not similar based on whether those angles match. So I mean whether the sides are actually corresponding. So if they're corresponding, what's true about their ratios?
So one's half and one's square.
Yeah, they'd have to be the same. So I have to check and see, is 10 over 8, does that equal 4 over 2? No, so that'd be another not similar, because the ratios don't match. So if you have sides in your similarity triangles, you have to match up, you have to check and see if they match up. What number would make these true?
8 changes to 5.
Yeah, so we could change 10 to 16. If 8 changed to 5, then they'd be similar, right?
Yeah.
Okay, so your assignment, let's look at our calendar real quickly. So your assignment today was going to be numbers 4 through 48 evens, which is like 25 problems or 24 problems on big ideas. But then we looked through it. We know a lot of people have to finish your test, and we also needed you to have a few of the similarity problems. So we went through, it's split into 2 assignments on big ideas now. Each one's, I think it's like 18 problems total, and they're pretty easy ones. So if you have to finish your test, you're going to now work on your test. If not, or as you finish your test, go ahead and get on those and work on those assignments, okay? So